Okay, good afternoon, everyone, and welcome. This is grade 9 coding. Right, this is grade 9 coding. It's the 27th of July. We are looking at functions with harvester. Puzzle 9 to 14 is what we're aiming for. And then after that, we're going to jump into review. So for those of you that might not know, we are doing informal assessments this week. So that means that we are going to review the content, not the actual puzzles, but the, what do I want to say now? The concepts and the ideas about what we are going to be having our informal assessments on, okay? So our assessment will be on the 29th. So for some reason, the entire of last week, I thought that the 29th is on Friday, but it's not, it's on Wednesday. So that's okay, because for us, we're just doing these things practically. Doing it in another way doesn't help us. So we're fine. We're good to go. Even if we needed to have it today, that would have been okay. Right? So it's going to be a bit different for coding. I'm not going to let you do it during class time because it's just not doable. There also isn't really a way for you to cheat. So what I'm going to do is just continue with reviewing the major topics for the rest of the week. Whether we were having assessments this week or not, I would have reviewed anyway. So that doesn't matter. And then you will get onto the website and download the link. Okay. Sorry, let me just check here. I saw a notification that, okay, it's not on my lesson. Okay, that's fine. So you will get the link, or you can go to the website, download the assessments. You'll find the links to the puzzles there. You can do them, and then we'll discuss them in class together. Okay. So that's the only way we can really do ours. We can't really do it during our lesson time. That's not going to work. So we'll just continue with the normal lesson on that day. It will be a revision lesson, however. Okay, that was enough of me chatting. Let's get to coding. That's why you're here, right? If you're on the YouTube channel, head down to the video description box below, and there you can find the links to register on our website. All right, so today we're back to a quote. And this quote says, from phones to cars to medicine, from phones to cars to medicine, technology touches every part of our lives. If you can create technology, you can change the world. And this is said by Susan, and I am not too certain about how to pronounce that name, but let's say it's Wojcicki, perhaps. Almost sounds okay. Anyway, she's the CEO of YouTube, right? So you need to understand YouTube's algorithms they're quite impressive, okay? The way that they do things. But what is interesting for me is how these people that are working in the tech industry, and I mean, we've had quotes here from Steve Jobs, from Mark Zuckerberg, Bill Gates, now the CEO of YouTube. I mean, they all have this vision of how technology, and specifically computer science, is involved in almost everything that we do, right? And it is a fact. Even the medicine that is being created to help solve or combat this pandemic that the world is facing is going to be reliant on a computer system. The way that they make that medicine and test it and keep track of the data and all of those things, right? So that's quite impressive. And I fully agree that if you can create technology, you can change the world. You need to remember that even design and engineering, need programmers. So if they design a rocket, or they design a probe, or they design a new piece of medical equipment, if it is going to be electronic and it needs to have any sort of computational function, there will have to be a programmer involved in that entire process, right? So any and everything that is going to have some sort of process that will be computational will need a programmer to be involved. Okay. Right, so terms that we should know. Sequence, the main logical structure of algorithms or programs, right? Functions, a sequence of code that performs a task or calculates a value. Easy to understand. So we just need to review this quickly. Every Monday, I just go through the platform just to make sure that everybody is on the same level for the week ahead. So these are action blocks, okay? So our toolbox is looking a little bit different. So action blocks will make the character do something, okay? Like move, turn, pick, whatever. It might differ from puzzle to puzzle. The loops or repeat blocks, they will make a sequence repeat. So actually, I like to call this a repeat block, and then it creates a loop inside it. It's going to make a sequence loop. Next, we have conditionals. So these are conditional blocks, and this is an if statement. This is an if-else statement, okay? And what this is saying is it checks for certain things before doing something. It checks for a condition to either be true, then to do something, or if that condition is not true, to definitely do something else. With this one, it's just going to follow whatever comes next. This one is going to execute that statement that we have in there. Again, we have conditionals. Now, I have this here again because these are repeats, but they are conditional repeats. So you find them under the conditionals as well. This means as the conditional is looking for certain things and adjusts the way that the code is executed, so does the conditional repeat. It is first going to look for a few things before it decides how to execute the loop. Okay, and then the last one, functions, allows you to call a specific frequently used sequence over and over again. Right. So the homework for last night, from Friday, was this one. Okay, we'll look at it on the platform as well. But there we basically created the function. There we called the function into a sequence. Okay. So we are looking at functions in Harvester. I just have to do something before I share the link. Give me a second here. I just want to make sure. Okay. Okay, awesome. So now you are ready, you have the link. So what you can do is click on that, and then you can go to the platform, and then we'll quickly talk through this one together. I'm going to start it over. Right, so what this says is functions let us do more with less work. Create a function that sends the harvester down a square path to pick a single head of letters from the middle of each row. So here we have 4 sides, and we have a single piece of letters in the center. So we can easily create a function here, and you can call this whatever you want. Pick a long path if you want to, or you can say harvest the path. It doesn't matter. You just need to remember what you called it. Okay, so I'm going to go with harvest path, meaning I want to harvest everything within a path. So the actions are pretty straightforward. We move until we're on top of it. We pick the letters, and then we move again. Now, to test this function, you need to make sure to place the function here, right? If you just create the function and you don't place that function there, you click run, it's not going to do anything. I do this often. I create the sequence within a function, I forget to put the function there, and then before I know it, it doesn't work when I try to test it. So just make sure that's there. So that obviously works, right? So now the only thing that I really need to do is to take this function and repeat that 4 times while turning in between. So we can either do this, well, actually this is going to be almost the only way for us to do this. 4, and we're going to turn right. And there we go. So what somebody else did was they placed this in here, and they did a turn right there, and they did this here. As you can see, it's the same results, okay? But I try to not place the entire sequence within the function. The reason is simple. The chances of you having another, let's say you're writing a large program, right? The chances of you having another need for a function that does this is more likely than to have the need for a function that does an entire square, okay? So let's say they double the square up. Now you can actually use this to continue even further on. Whereas if you only do the square, you can do the square again, but here we have a picked letter. So let's say you do this square, and there's another one here, and this one is shared in between. Then you're going to try and harvest that one 2 times, right? So what I always try to do when I'm creating functions is to make sure that I have a large enough sequence that I'm actually winning by using this, right? And not just having a single statement that I place into a function, unless I'm limited in here to only have one available. But if I have a single statement and I can use it over and over again, I'd rather just use the statement. But if it's something that's actually going to perform an entire task that I think will be useful to use over and over again, then that's the one that I place into the function. And there they've gone and done it, but they've placed 2 here. So it's going to be up to you. So here they say, try writing your function again. Is it still helpful? How can you make it work for this puzzle? So we're going to just create that same function that we used. If you used another one, that's fine. So we said that our function does this, and then it picks the letters, and then it moves forward again. So we want to harvest the path, and we want to turn right, and we want to loop this, come on, 4 times. Okay. So now we obviously want to do this one as well. So we could just turn right again and repeat the entire thing. twice. Okay. So now you can see how we use that same idea and used it in a different application to achieve something almost similar. Okay. So if you did create this in here, let's check how that would have, what that would have looked like. So this one then obviously wouldn't be harvest path, but rather harvest square. So if we harvest the square, that's what that looks like. Then we can turn right again and you loop this twice. So really it's going to depend on you. You can see with functions, there are many different options, right? You stay within the block limit, so we're okay. But you can choose to do very little here and do more over here, or you can do less here and more over there. It's really going to depend on you. Okay. Now this is going to be fun. So by the way, I've set the chat to public now, so just behave. But quickly send me a yes if you are there and you've logged in and you're ready to code this. Okay. Right. So with this one, again, there are a few different ways you can do this. But the first step is you need to create a function. And while you create that function, place it in there so that you can test it as you go. I'm going to start again with the harvest path solution. Okay. And now I'm going to try and see if I can't do that other one, the other way around. I'm going to call it that while path ahead. I want you to move forward. And I want you to, while there is lettuce, pick lettuce. Well, let's try this and see. Okay, it works beautifully, right? And then once the path isn't there anymore, I want you to turn right. So let's try that again, and that works. Okay. So now we can repeat that, obviously, 4 times. Okay. So what happened here, actually, I wanted that to happen up there. So we need to sort of figure out how we're going to do that, right? So you can see here, while the path is ahead, she just continued past that. Okay. We still need to get those two. So let's do this 6 times. Come on. Testing. Remember, problem-solving workflow. We identify the problem. That's going to keep giving me hassles there. Then we create the solution. Then we test the solution. And so it goes. Let's see if we can't do this. If path to the right. We want you to turn right, but I want this in here and that out. So that's going to skip that again because there will be a path ahead constantly. Place it in here and see. That's just going to put us in a square. Okay, so I knew that this wasn't going to work from the beginning, right? I've been showing you the solution since the start, but I wanted to show you what you can do to sort of experiment and see how you can use different blocks to get to the solution, okay? So obviously it would have been nice to use these repeats and all of that, but in my opinion, just keep it as easy as you possibly can. Why do you want to make it more difficult for yourself? So this has worked beautifully with that and a loop that says this. So that's worked beautifully without any hassles. And we know that this will also work. And now we can see we're facing here. So if we turn right again and turn right and we move 1, 2, then we can just harvest that this way around. So let's do that. Turn right, move forward twice. Loop times 4, harvest path, and turn left. Let's see if that works. Okay. Now, this is why I did all of that stuff earlier, where I used all those repeats and all the turn rights, and it's the same as if you were doing the entire square in your function. If I had this entire sequence here inside my function, I would have had to use more moves to get her lined up in here. She would have had to have faced this way to our left, right? Because the turn in here is to right. So she would have had to go around this way. But because we have the harvest path and only that, we can choose if we wanted to go left or if we wanted to go right by just adjusting this here. Okay, so I want to show you the other way. If this was our code, because you can still do this, right? You can definitely still do this. And this needs to come out. Let's just test this and see. Okay, so that obviously works. Then you can turn right here and you can loop this twice. Come on, where's the loop? Okay. Now for the movement, you'll see what needs to happen. We're going to turn right and move forward again, and then you have to turn left again before you can call the function, which is still doable by all means. Okay, so there you can see this one now uses 15 blocks of code, but there's more of these funny movements in here. So one is not wrong and one is not right. It's just a matter of getting it to do what you want it to do, right? I like the fact that she can just continue up here and come around this way. That's a nice pattern for me. If you didn't mind her turning again and going around that way, that's also fine. It's all up to you. Or at the end of the day, if you're actually creating a game and she has to move in a certain way, or coding it for a customer and they want it to look and feel a certain way, then you need to follow their idea and their thing. Oops, let's run it again and then we can continue. Okay. Use everything that you've learned so far to solve this puzzle in 19 blocks or less. Okay, so they've given us some functions. Now, in order for this to work, we must first make sure that we understand what all these functions are going to do. We must know how they will act. And we can do that by just reading them, right? So this function says check square for corn. If there is corn, pick corn. So this is why I said read it. Make sure you understand it. Because the check square for corn is not only going to check, it is also going to pick if it is there. So yes, it's going to check for the condition, but it will also pick the corn if that condition is then true. And if the condition is false, and this is also very important to understand what's going to happen then. In this situation, it'll just continue on to the next statement. Just continue to execute the rest of the sequence. Okay? If that was an if else, it would have been a different situation. And that's why I say you need to make sure that you understand both the ideas. If the condition is met and if the condition is not, hasn't been met. Okay. So the next one says get all pumpkins. It says while there are pumpkins, do pick pumpkins. We can see it has no moves in there. It's not moving. It's just picking the pumpkins while it's there. Okay. And then over here we have a pick along path. And that says repeat until there are pumpkins. Check the square for corn and move forward. And then at the end, get all pumpkins. So it's going to repeat this as long as she's not on a block with a pumpkin. The moment she's on a space that has a pumpkin on it, then that loop will stop. Okay. So now we need to code all of this in here. So let's start with the easiest problem first. From there to there, do we have a function that can do that? This one? No, it doesn't have a move in it. This one also doesn't have a move in it. This one, it does have a move in it. So let us try it and see whether we get an error or not. This one. and we haven't gotten any issues. Perfect. So one thing that's important to understand here is we call one function, but we are using all three, because this one function is calling that function and this function into itself. Not into itself, into it. So this is being run here, and this is being run here, and that's being run there. So all three of them are being run here, executed here. So every time you call this function, these other two will also be called. Not individually, but within this one. Okay, so now that we've done that, we see that we want to turn right. And we also see, challenge, we have only two turns, right? It's not two turn rights and two turn lefts, it's two in total. So now what we need to do is we need to repeat this 4 times. And test it. And here you can see she's facing this way. So this square has been solved. Beautiful. Now we need it to come here. So the way to do that is by using that other turn that we are limited to using. Turn right. Let's test that and first see if it is actually going to make a face and line up the correct way. And it does. Now this wants us to come all the way down here, there. So let's figure that out. If we use this function, no, not that one. Will it work? And yes, it does bring her all the way down. And once she's here, this entire thing actually becomes the same as this. Another square. Over there, coming down, over here. But this is the first one. So instead of doing that, can't we just repeat everything twice and see whether that'll work? And look at that. So we've done it in 17 out of 19 blocks. So let me just show you what they had in mind. Was to do this and then say pick a long path. And we can't do that actually because now we're out of turns. So that's an interesting idea. Very interesting. Okay. I'm not sure what they wanted, but this will work. And then we're using less, so that's good. Unless if you edited one of these to add a turn into the function, because remember, if you have that turn in that function, you can call the function 100 times. So even though you only allowed 1 or 2 turn blocks, if you have those turn blocks in the function, you can call the function over and over again, essentially giving you more chances to use the turn block. This veggie is unknown. It changes each time you run the program. Ooh. Solve this puzzle in 23 blocks or less. Each sprout will either grow, 1 corn or nothing. To find the best solution, you will need to edit the functions directly. Let us just test one. Pick a long path is saying repeat until there are pumpkins. Okay, so I can't really see any pumpkins. So that's going to make us repeat forever. So we need to find something else to do there. Then we want to check for corn. If there is corn, pick corn. So they say it's either going to grow one or nothing, so that's fine. But we need to harvest these lettuces somehow. So what I'd rather do is to create this function to say harvest steps. And just change the function to something that we can use, which is going to be a move forward. First problem. Second problem is we need to turn right. Third problem, we want to move forward again, and then we want to turn left. If we test that, it works. 1, 2. And we obviously need to, not there, over here, collect the lettuce. While there is lettuce, we want to pick that lettuce. Okay. So when we do that twice, we are lined up completely for this. Awesome, right? Now I want to actually just change this. Instead of saying check for corn, I want to call this harvest path. And we can just call it corn like that because we know that this will be corn, right? So what we want to do there is we want to move forward as long as there is a path ahead. And we want to check for corn all the way through. Okay, before we can test it, we need to add it in here. I told you I do that often. That worked. From there, we want to obviously turn left. You can see that. And we want to repeat that thing 4 times. Okay. So now we're here facing this way, which seems very similar to the top there. Oh no, I chose the wrong function. We want to harvest the steps, not just the corn. Awesome. Sometimes the program self-terminates. So to do it this way can also work on some of them, but not on all of them, because some of them will, after we've harvested that last step, still trying to execute that. And there you can see it's trying to execute that. So it works, but I mean, it's not really, if this harvest wasn't a conditional, let's say this was a you have to harvest it, right? Just the statement. We would have gotten an error there at the end after we've actually completed the puzzle, because then the puzzle or the program would have tried to run that last one. It would have tried to force a harvest to happen or a picking of a crop to happen. But in actual fact, it can't because it's not there, right? So that's why, if you take a look at it, we added one block to get the repeat. But if we take the repeat away, the big loop that we nested everything else inside of, and we add just the harvest steps again at the bottom, that's also just adding one block. But now you have a clean finish, and there's no risk at accidentally triggering an error for no reason, okay, or for an unnecessary reason. Right, so here we have to read and decide. So what will we read and decide? Well, we're going to read this and decide which answer is the best one. And this is going to be your homework. So answer that question, and we will discuss it tomorrow. And I hope you're practicing. Oh no, the homework is supposed to be something else. Let me give you that homework as well. There's 2 for homework because the other one is actually a lot of fun. Just let me go there quickly. So as you can see, they've switched around the lessons, right? There we go. So those last 2 are homework, right? One is answer a question. The other one is literally one block that you need to code, okay? And this person here is there to make it look like it's extremely complicated. But I want you to get to the point where you're moving the agent and then you're coding the agent and you're moving the player. That's why I want you to just do that first one so that you can see how that works, okay? Right. And then tomorrow we're going to continue with this. So you'll see we're going from lesson 17 to lesson 16. It's because it was the other way around when we started. Now it's flipped anyway. Doesn't matter, okay? This is a very fun one to do. Thank you so much for being here. Invite your friends to join us. And then if you have any questions or you'd like to share the homework screenshot with me, you can do it to that email. And have a lovely day further. Bye.